Dear students, today we are going to study the unit number 5 from your syllabus, which is consist of drugs acting on the endocrine system or the endocrine glands. Okay, so these endocrine glands, they are going to secrete some of the hormones which are going to show us some kind of potent effect. So now, especially in our syllabus, what we are having is the sex hormones, drugs for erectile dysfunction, oral contraceptives, corticosteroids, thyroid and antithyroid drug. Most of these agents we are using them for treating the variety of the diseases. Now, today we are going to start with the first topic, that is the steroids, which are having a multiple fold of pharmacological action. So, upon completion of this topic, you will able to understand the chemistry of drugs with respect to their pharmacological activity. You will going to understand the drug metabolic pathway, adverse effect and the therapeutic value of the drugs. You will able to know the SAR of this class of the drug, and you will going to study a chemical synthesis associated with a given example in the syllabus. Okay, so let us first get acquainted with the steroid. Now, since from their identification in 1935, steroids have served as a wide range of uses. Initially, these steroids, they have been isolated from the adrenal glands, where it was initially used in a patients who are suffering from Addison's disease. Now today, many of the clinical roles of steroids are related to their potent anti-inflammatory and immunomodulating properties. Now, though these steroids, they are having a multiple folds or some of the good pharmacological action, but their side effects are ranging from common to problematic side effects, ranging from a minor case of acne to a Cushing syndrome that may be result in diabetes mellitus or some of the potentially life-threatening diseases like the diseases of the heart if the side effects remain untreated, isn't it? So now, these steroids, they include the different compounds having a variety of pharmacological action from hormones, vitamins and cholesterol. Now, for better understanding of the steroid, we can divide them in different classes like corticosteroids, sex hormones and oral contraceptive agents. So, essentially, or what chemically steroid is, it is 1,2-cyclopentano phenanthrene skeleton, isn't it? So steroids, they are chemically 1,2-cyclopentano phenanthrene skeleton. Now you are going to observe on your screen the four rings are fused with each other, who have been named as A, B, C and D ring. Okay, so now let us try to understand how we are going to give a numbering to this steroid skeleton. So now, if you're going to observe this, the numbering is going to get start from ring A, wherein it is 1, 2, 3, 4, 5. Then the numbering is going to cover the ring B, 6, 7, 8, 9. Then the numbering is going to cover the ring C. So now after 10, it is 11, 12, 13, 14. Then it is going to cover or the wrap ring D. So this is the way how we going to give numbering to this steroid nucleus, isn't it? So now if you again see this, numbering is going to get start from ring A, going to wrap this ring B, then jumping on ring C and then D. So now let us see the next part of nomenclature and the numbering. Whatsoever steroid that we are going to discuss, they are either the derivatives of gonane, estrane, androsten and pregnane. So now if you are going to observe their structure, the structures are like this along with the numbering. So now look at the first structure, that is the gonane. So gonane, you can call it as like 5-alpha or beta gonane. So the total number of carbons present in this gonane, they are 17. Now look at the estrane. It is the estrane. What is the main difference between gonane and estrane? In case of estrane, we have added one beta methyl group and we have given the numbering 18 to it. After 17, it is 18. So it is the estrane. So now after the estrane, the next in this category is the androsten. Okay. So what is the difference with respect to the estrane? We have again added one more carbon atom in between ring A and ring B, that is the beta methyl group, and we have given numbering 19 over there, isn't it? So this is the androsten, and the last is the pregnane. This pregnane is also have one more additional or two additional, not one, two additional carbons which are above carbon number 17, which is located at the D ring. So it is the 20 and 21. So now again look at the total number of carbons starting from the gonane. Gonane has 17 carbon, estrane has 18 carbon, androsten has 19 carbon, and pregnane has 21 carbon atom, isn't it? So now this thing is, or this nomenclature and the numbering system is a basic in a steroid molecule. We have to understand while giving the IUPAC name, first we need to understand in which chemical skeleton your structure is there. So right now we have studied the four skeletons: gonane having 17 carbon, estrane having 18 carbon, androsten having 19 carbon, and pregnane, it is having the 21 carbon atom, isn't it? So first we have to learn, first we need to understand these four basic nucleus, which are very simple to understand. Now let us study the another part in case of nomenclature, stereochemistry and the numbering. Now when we are going to give the numbering to the steroid skeleton, okay, we generally see that the stereochemistry of the hydrogen at C5 is always indicated in the name. Now what is the importance of mentioning the stereochemistry? What we are mentioning in the name is that 5-alpha or 5-beta. So now what is meaning of alpha and beta? This 5-alpha represents the thing that the hydrogen at 5th number carbon atom, it is on to the dashed bond. It is on to the dashed bond, or it is on to the dotted bond, isn't it? Okay. Now this hydrogen, if it becomes the beta hydrogen, okay, then the juncture between A and B ring, it is going to get changed. Now let us see this. Okay, so now if the hydrogen at fifth position of ring A is on the dashed bond or alpha, we will get trans AB junction, isn't it? We will get the trans AB junction. If the same hydrogen is on the wedge bond, if it is on to the wedge bond, then the junction between ring A and ring B is the cis junction. So this is the importance why we are stating the stereochemistry of the carbon atom at number 5 with respect to the hydrogen, isn't it? So now if you are going to observe both of these structure, the methyl group in both of these 5 alpha androsten and 5 beta androsten, these are axial in nature, isn't it? Okay, so we have to keep this thing in the mind. If it is 5 alpha, then the trans junction exists between ring A and ring B. At the same time, if that hydrogen is the beta, or if it is onto the wedge, then on the wedge bond, then we will get the cis AB junction. So that is the importance, isn't it? Now, one more important point, changing the stereochemistry of any one of the ring juncture or backbone carbon, it will going to change the shape of the steroid, like we have seen in our example. Now let us see what is the criteria about mentioning the double bond in a steroid molecule. Now if the double bond in any of the ring of the steroid is not in between a sequentially numbered carbon atom, then both carbons are indicated in the name. Now when the methyl group is missing from the side chain, this is indicated by the prefix nor with number of that carbon atom which has disappeared. For example, norethystyrone, wherein the methyl group is missing. Now let us explore our first point about the double bond. Now if you see the structure that has been written below, that is the structure of delta 5 androsten. Okay, delta. So now this delta is used to designate the carbon-carbon double bond, isn't it? This delta, the symbol delta, is used to designate the carbon-carbon double bond in a steroid. So what is the meaning of delta 5? Delta 5 indicates it is a double bond between the carbon number 5 and carbon number 6, isn't it? Okay, so now whenever you are going to observe any IUPAC name of the steroid, and if you are going to observe the sign like delta, so always remember delta means it is the indication of the double bond, and a superscript letter written onto that delta indicate the position number of that double bond from where that double bond is going to get originate, isn't it? So now delta 5 in the present example indicate that double bond is going to get originate from carbon number 5 and it is going in sequential manner up to 6. Okay, so now what happens when the double bond is not in a sequential manner, isn't it? Now let us look at the example. Okay, extra 135 in bracket 10 trine 317 beta diol. Now if you look at this structure, okay, you will observe that this double bond between 5 and 10, it is not in a sequence. So if I want to designate this double bond using the symbol delta, then what I will do, I will write delta 5 in bracket 10. Okay, so delta indicates double bond and where that double bond is present, it is in between the carbon number 5 and carbon number 10, isn't it? So this is the way how we can represent the double bond, position of the double bond in the steroid molecule. Now let us study more about the stereochemistry of these steroid skeletons. So now in the gonane we will going to observe total 6 chiral carbon atoms. So which are those chiral carbon atoms? The carbon atom located at 5, 8, 9, 10, 13 and 14. So the chiral carbon atoms in the gonane, they are located at position number 5, position number 10, position number 9, 8, 13 and 14. So now as there is appearance of such multiple number of carbon atom in a steroid structure, we can have the n number of isomers arising due to the chiral nature of those carbon atom. So now if we are having 6 chiral carbon atoms in a steroid skeleton, we will get 64 optical isomer owing to the presence of 6 chiral carbon atom. Then if the chiral carbon atom, they are going to get increase again by 2, that means if we are having the 8 chiral carbon atoms, then we are having 256 numbers of optical isomers of the steroid molecule. If we are having the 9 chiral carbon atom, then we can have 512 optical isomers of that steroid skeleton. Okay, so this is the importance of understanding the chiral carbon atoms in a steroid, isn't it? Okay, so now this is all with respect to the generalized introduction and the nomenclature of the steroid.